Okay, everybody, in this video, what I wanted to do, real short video, I think, it will be short anyway, is to take a look at the reference table. So I'd like you to get out your Earth Science reference table. Let's open it up to page 13, and we've looked at page 13 before a little bit. We've got our temperature scales here. We spent some time talking about those. We took a look at air pressure in another video. What I wanted to focus on in this video were these components down here, the station model. And station model is something that we've talked about a little bit, but again, not a lot of detail. When you look at a real weather map, one that has the actual station models on there, there's going to be a lot of information. And now that I'm thinking about it, I'm going to pause the video just for a moment and pull up today's weather map. But this time, the weather map's going to have all of the data and all of the station models on it. So I'll be right back and pull. Okay, so we're back, and here's today's weather map, which I haven't talked about today's weather, but in any case, today is Thursday, April 7th, and we can see this large low pressure over here going to move into our area. We're looking at a significant rain event for Thursday. We've got an occluded front, warm front, cold front. And if you watched the videos about fronts, the cold front catches up to the warm front. Where they meet, we then get an occluded front, and then this is the beginning of the end of the storm. But in any case, that's not really what the point was. The point was to take a look at the station models. I'm going to zoom in a little bit more so we can see them in more detail. Each one of these circles represents an actual weather station on the ground, and the data represents the information that the weather station collected. So here we have air pressure, here we have temperature. The lower number is the dew point temperature, and this is just kind of an abbreviated way of presenting the information from the weather stations on a map. And so if we go back to the reference table, here's our station model, and the station model actually contains a tremendous amount of information, even though it looks relatively simple. It's a circle with a few numbers. What's nice for you is that on your reference table, everything is explained. There's a legend here that tells you what all of the different numbers mean. So in the upper right, we have our air pressure. Remember, it's coded, and you have to convert that by either putting the 9 or the 10 in front, moving the decimal point. So they give us an example. In this example, 196 millibars would actually be 1019.6. We put a 10 in front, move the decimal over 1. We have air temperature in Fahrenheit. On this particular day, air temperature was 28. Okay, the next number down is visibility. How far you can see. You've probably noticed that on some days the air is clearer, and on other days the air is kind of hazy or maybe is foggy, something like that. So this number gives you an idea of how far you can see. And remember, most station models look like this over here. In the big box, they're explaining what everything means. On a real weather map, it would just be assumed that you would know what all these numbers mean. Okay, the lower left, we have the dew point temperature. And remember, when the air temperature and dew point temperature are close together or the same, we're either at or near saturation, which means rain, precipitation. And we can see the star-shaped symbol. This is where the present weather symbols are. So we can see down here, a star represents snow. So we have snow for the precipitation, and that makes sense. We have a very humid air mass. 28-degree air temperature, 27-degree dew point. That's the recipe for snow. If we saw these other symbols here, there's symbols for sleet, freezing rain, fog, and so on. And again, you don't need to take the time to memorize any of this. It's right here for you in the reference table. So we've got air temperature, visibility, dew point, air pressure, precipitation amounts in the lower right. In the past 6 hours, so in the past 6 hours, 0.25 inches have fallen. Now this middle number on the right side, this +19, is something that sometimes confuses students a little bit. It's barometric trend, air pressure trend. You know, just knowing the air pressure by itself is not all that useful. What's more useful is knowing if the air pressure has increased or decreased. Remember, if air pressure decreases, that means that we're looking at precipitation. If air pressure is increasing, then we're looking at weather improvement. So the trend is what's more significant than a particular air pressure. And here we have a +19 with a slash. And this means that we had a steady rise of 1.9 millibars in the past 3 hours. So sometimes a common regions question is to ask you what the air pressure was 3 hours ago. And then you would do 1.9 and subtract it from your 1019.6. If it was a minus sign, and if I remember right, the slash goes the other way, that means that instead of a rise in the past 3 hours, air pressure has declined or has decreased in the past 3 hours. So this gives us an idea of what the trend is, what the pattern is, whether air pressure is on the rise or decreasing. And that really is almost more important than just what the air pressure by itself is. You want to know how the air pressure is changing. One air pressure doesn't really tell you much, but you want to know if it's improving or getting worse. We've got our present weather down here. And then wind direction. Okay, so this gives us the direction of the wind. And remember, it's where the wind came from. So in this case, the wind is coming from the southwest. Sometimes on the Regents exam, they might say something like, which direction is the wind going? And then that would be the northeast. So you really have to pay very careful attention to the wording of the question. And then we've got the wind speed. These little feathers, they call them feathers on the side. A whole feather would be 10 knots. A half feather represents a wind speed of 5 knots. A knot is similar to a mile per hour. It's usually used in aviation for flying or for shipping. The Navy uses knots when they calculate the speed of a boat. So it's just a different measurement for speed. But it works very similarly to miles per hour, and it's not all that different than miles per hour. So here we have a total wind speed of 15 knots coming from the southwest. Now, also on the bottom of this page, we have some other information. We've got the air masses, and I talked about these in another video. Continental Arctic, continental polar, tropical, maritime polar, and the symbols that go with those. You also have the symbols for your different fronts. You've got the symbol for a cold front, symbol for a warm front, stationary and occluded. And then also on some weather maps, we haven't gotten into severe weather yet, but you'll see a hurricane symbol, which is going to look like that. And on some other maps, you might see a tornado symbol, which would look like this. Okay, while I have the reference table open and up, a couple of other things that I wanted to just show you. I think I showed you this once before, but here we have the layers of the atmosphere and the temperatures changing, air pressure, and water vapor in the atmosphere. Notice water vapor pretty much drops off by the time you get to the stratosphere. All of our weather takes place in the troposphere. Now over here we have the planetary wind pattern, and this was something that we went over in the class notes in one of the wind videos, and it's here for you. So it's not something that you have to commit to memory. We already went over this in another video. If you don't remember it that well, you might want to go back and take a look at that. Remember, I'm not taking down any of the videos. You can go back and look at any of them at any time, and that would be a good thing to do. But anyway, you have this here for yourself to look over. So those are all of the weather charts, I believe, in the reference table. And then you've got, of course, relative humidity, dew point, and then all the way back at the first page, you've got properties of water, specific heat, gradient, which you would need for pressure gradient, things like that. But for the most part, that's it for the weather out of the reference table. So anyway, I do intend to give you some homework working with the station model, and I'll update Mr. Abate with that information. So that's it for now. Good luck. Bye.